Okay, I'll do.
And I'm selecting measurement technique. And this is a initial topic, not difficult, not very easy. This is actually now, it was initially two chapters, physical quantities and measurement. They were separate chapters, and now they have merged them in a single chapter. But in the file I have, there are two separate chapters. I'm starting with a question. A student measures the length L and period T of oscillation of a simple pendulum. He then uses the equation to calculate the acceleration of free fall. Measurements are there, calculation of G. So he's willing to do calculation of G. So I first square both the sides. And you know why? Because I have to make G as the subject. He's asking for percentage uncertainty. So I have rearranged the formula, and when you are taking the percentage,
Why did the G become 8?
G, no, it never becomes 8.
It's written 8G.
Oh, acha. Actually, it's a typing issue. Na? I was writing Deba. So I think
Okay.
Deba turned to be that. It's not, definitely it's not. Now you have to help me solve the do the calculation.
It is 2.86.
Sorry.
2.86.
A steel ball is dropped and fall through a vertical height h. The time t taken for fall is measured using light gauge. The results are given in the table. The acceleration of free fall is calculated using the equation shown. So I have the equation. So it's a percentage uncertainty in G.
It is coming as 4.6%.
Can you repeat 4.6%?
Yes.
The diameter of a spherical golf ball is measured with calipers and found to be this. The volume of the sphere is this, where D is the diameter of the, what's the volume of the golf ball? So let's work out the formula first. First, I think because here is asking for absolute value and the uncertainty both. 4.11.
The V is coming as 36.35.
36.35 and 0.01.
So in this, the 36.35 will be multiplied instead of the 100.
Yes, because this time it is not a case of percentage.
The uncertainty is coming as 0.265.
Sorry, how much?
0.265.
So making the uncertainty for one significant figure
So also the 36.35 will be rounded.
I think after looking at the options,
Well, only D is matching with 0.3.
it means that he has rounded the a calibration curve is shown for an M meter whose scale is inaccurate. Two readings taken on the meter at different times during an experiment are 0.13 and 0.47. How much did the current really increase taking the two readings, ammeter readings? So 0.13. So where should a 0.13 be there? 0.1, 0.12, 14, 16, 18. So it should be here. This is 0.13 and 0.47. I was planning that we should read the values.
Okay, so it is like between 0.12 and 14, the first value. So it's 0.13.
I'm getting 0. Is it, don't you think, is it 0.12 or 14?
Almost 1.4, I think. Yes.
And this one is
4.4.
0.44. So the answer is coming to be option A.
Okay. So we don't have to take into the account like the initial reading even at 0.
No, because the graph is covering both of them. It's a calibration curve now. It's a calibration curve, even though calibration curves are not in our course anymore in a title name. So, but still I'm covering them because sometimes it comes from the O-level background. A student wishes to measure a distance of about 10 centimeter to a precision of 0.01 centimeter. Which measuring instrument should be used? 0.01. So whose least count can handle that?
So it will be like something like a 1-year caliper because the rest are bigger. 1-year.
Because tape measure and meter rule are point is 1 millimeter.
Okay, so like 10 centimeters, 0.01 centimeters will be equal to 1 millimeter, 0.1 millimeter.
It's a least count, na? So now the tie is between micrometer and vernier caliper.
So it's D.
Yes, it is D. A student using a CRO to measure the period of a signal, she sets the time base of the CRO to 5 millisecond per centimeter and observe the trace illustrated below. The trace has a length of 10 centimeter. So what's a period? Period means the time for one cycle. Now we can check that how many cycles are there. 1, 2, 3. It looks to be 1, 2, 3. It looks to be 3.10 centimeter. It's 5 millisecond per cm. So if I get it on 1,
Like we'll find out how much time it takes for one cycle to be completed by this.
because I am getting 0.35 cycle in 1 centimeter, and 1 centimeter is equal to 5 millisecond. I think you're right, because that would be much better. Instead of taking it to 1 cm, I can take it to 1 cycle. That would be better.
It is coming as 2.86.
So let's see what we get. But unfortunately, we should first convert it into millisecond. Actually, anyways, you first multiply this.
It is 14.3.
It's a 10 power minus 3 also, no?
No, only 14 point. Okay, okay. From the millisecond, so it's 0.0143.
But can you convert it into scientific?
1.4 into 10 power minus 2. So D.
Yes. Which two quantities are both vector quantities? That's a memory question.
D. Force and momentum.
The diagram shows a force Fp is the horizontal component of F at an angle theta to F. Now that's an interesting question, and as you are not taking math, so you can try it in a knowledge base, because it says what happens to the value of theta of the magnitude of P. So the magnitude of P is obviously P would be equal to F cos theta. You can take any value because it's a case of understanding the relationship. So P is the horizontal component of F. So first I will write P is equal to F cos theta. Now, how I tackle this relationship, because it's a pure mathematics now, P is equal to cos theta. So if a person is not taking maths, what the person can do, try some values and get the values.
So by increasing the angle, the cos theta will decrease the value.
You should see the values now.
Because cos 0 is 1,
Cos 0 is 1, right?
cos 30 is 0.866, cos 45 is 0.7, cos 60 is 0.5, and cos 90, I think it will be 0. Yes, it's
0.
0. So by increasing the theta, the P is decreasing.
So it means our option is narrow now.
C will be wrong because it shows an increasing gradient.
And A is showing, and A is better in an option.
But why is B wrong? Isn't it showing like a decreasing gradient?
But B is showing that P and theta both are increasing together. Our working shows that P theta increases and P decreases.
Okay, so initially they are increasing like the Hooke's law. That is why it's wrong.
They're somehow increasing and decreasing.
Okay, and D is also like that.
Yes, this is the same problem. P and R are coplanar vectors. Examiner says X is equal to P minus R. Plus and minus are different in this respect. Another way of solving this type of question, like now you see that it shows the two options. Now you have to see the options here, which will follow the diagram here.
B shows like the head to tail of X and R, giving a resultant. X and P giving a resultant.
But they are not combining in the equation. How such a big vector is coming from them? If I join them,
X plus R is equal to P. So A is showing like the head of X and the tail of R.
X plus R, right. X. I made a parallelogram, which is a famous thing. Just revising because it's a very good thing to remember. What is the difference? I don't know what's the difference between, if I'm making a mistake, what's the difference between C and D?
Is it like the lengths of P and R?
I don't know. It's a very strange thing. Maybe I'm missing an arrow because the green arrows are coming on it. Let me check. Arrows are opposite actually. Oh, it means that's what I was thinking, that what's the difference? Actually, the arrow is not downward here. Arrow is upward.
So it will be like a negative sign then.
It means there is no resultant. No?
Yes, there is no result.
All vectors are being added.
So in this D, it's P plus R is equal to X.
Because it fits on the thing which I had made there.
So A will be the answer as only it matches the equation.
Yes. After working out, it means that only A is the right option, because already we had worked out a measurement is taken correctly, but with a ruler at a significantly higher temperature than at which the ruler was calibrated. The higher temperature causes the ruler to expand. Due to expansion, the separation between the divisions will increase, because if a ruler will expand, the size of one division will increase.
So will C and D be wrong as they are giving like a wrong justification for the systematic error?
Maybe. What systematic error?
So I think like the systematic error cannot be fixed like by repetition.
When first we see, is it a systematic error? Because we do not know how much, because it is not mentioned how much temperature is increased. So maybe expansion increases it to 1 millimeter, maybe expansion increases the division size by 2 millimeter. The measurement will be subject to a random error. The measurement can be made more accurate by taking the average of several repeated measurements. The theory is right, but we have to decide, is it a systematic error or is it a random error? What is a random error?
It is caused by human negligence.
No, but the main concept, remember that if an error fluctuates, like parallax error, if an error fluctuates, it is random error. And if an error is constant, like if your clock is 5 minutes ahead, it is called a systematic error.
This will also be systematic error as the calibration will be the same, like difference it will give.
So one thing is clear, it's a systematic error. Systematic error is what? An error is said to be systematic if it is constant in magnitude. One amount of error is coming every time. Subject to a systematic error, measurement can be made more accurate by taking the average. Now it's a memory. Systematic error cannot be accurated, cannot be rectified by average. The measurement will be subject to a systematic error. Measure can be made more accurate, more precise. That's right. Two liquid and glass thermometers in a well-mixed liquid are individually observed by 10 different students. All agree that one thermometer reads 21 and the other thermometer reads 23. What's the possible explanation for the difference? The liquid is not all at the same temperature, but he says well mixed.
So precision is like the difference between the readings.
Precision means the values should be close to each other. This precision means the values are close to each other, and accuracy means that the values are close to the average value. The readings are not precise. So that's also wrong, because 21 and 23 are not close. Well, yes, actually, this is right. But he says possible explanation. Possible explanation why one is 21, one is 20, because there are two different thermometers, right? There is a random error affecting the reading. If it is a random error, it's not necessary that one is 21 and one is 23. Random means an error which fluctuates. Now we have a choice.
Like, aren't 21 and 23 close? No, can't they be precise? Or there's a large difference? Like in the difference between the thermometer.
Can you repeat? Sorry, what did you say?
So like the 21 and 23 are close, so can't they be like precise?
No, no, actually 21 and 23 are not very close. The point is that is it the precision is the explanation for the difference? No, because you know why the temperature is coming so much different, because there is one thermometer and the other. It's not necessary that maybe the calibration is different, or maybe one thermometer is not correct. I'm not sure which one of them, but the difference is quite large. Both are liquid in glass thermometers, but it is not a case of precision. Precision means you're reading. It is not possible that a person reading 21 and other reading 23, if both the thermometers are correct. So it shows that at least one thermometer is having some permanent error. Some thermometer, you can simply say that at least one thermometer is faulty.
So D will be the answer then.
Hmm. A circuit is set up in order to determine the resistance of a 12 volt, 1.2 watt lamp. When operating normally, an analog ammeter and analog ammeter voltmeter are used. Which ranges for the meters would be most suitable?
So first we'll take out the current from this, like power is equal to VI.
Very good. You're right. Because we don't have the current.
It is 0.1. So then the answer will be like A, because both the ranges are like a bit different but closer than.
It's looking to be a good range. Let's check other one also. 0 to 100 is too big. 12. Right. So this is A, and we discussed these questions. And as mentioned just in the start of